rotation, volume of solids of revolution. Now, definite integrals can be used to find the volume of a solid that is obtained by revolving a plane region about a horizontal or vertical line that does not pass through the plane. Now, this type of solid will be made up of one of three types of elements. We have the disks, washers, and the cylindrical shells. Each of which requires a different approach in setting up the definite integral to determine its volume. Now in this video, we are going to talk about how to calculate the volume by rotating around the x-axis or the y-axis using the disk method. In finding the volume of a solid, we are going to use this disk method if the axis of the revolution is the boundary of the plane region, and the cross sections are taken perpendicular to the axis of the revolution. Now, always remember that this method, the disk method, works by taking a cross-section area. So let's begin. Let's say if we have a curve, and our curve looks like this. And we want to calculate the volume of the curve from, let's say, from A to B. One method that we can use is a disk method. And that's what I have said earlier. This method works by taking a cross-section area. So this is going to be our radius. If we take the cross-section area, we can turn into a disk. And as we rotate the region about the x-axis, we can form something like a disk. Now, if we are going to draw this disk in the other way, we can notice that it forms something in the shape of the cylinder. We know that a cylinder has a radius r and a height represented by h. Now, the formula for the volume of a cylinder is basically the volume of the cross-sectional area times the height. We know that the volume for the cylinder is the volume of the cross-sectional area times the height. Now, the cross-sectional area being the circle on the top, which is the pi r squared. Thus, the volume of a cylinder is pi r squared height. And so, the volume of the disk. It has a height of h, which you can view as a delta x, and it has a cross-sectional area, which is pi r squared. Now, to find the volume of a solid, you need to add all the disks from A to B to find the volume of a solid that is obtained by revolving around the x-axis. To find the volume, you have to integrate the cross-sectional area from A to B, and the area is basically pi r squared, where r is the function of x. And so, this is the equation in finding the volume of a disk using the disk method. Now, let's have an example. If we have the function y is equal to square root of x, and we want to find the volume when rotating this curve about the x-axis. And we want the portion of that curve be in between the values of x is equal to 0 and x is equal to 6. So the first thing that you need to do is you need to plot the function. The square root of x looks like this. And the radius, as we all know, it is the distance between the curve and the axis of the rotation. In this case, we are rotating about the x-axis, and we want the portion of the curve between x is equal to 0 and 6. So technically, this is the region. You have to find the value of r of x. R of x is equal to y, and y is equal to square root of x. Now let's use the equation. The equation is the volume is equal to pi, the integral from a to b, r squared x dx. And then substitute values. Pi, the integral 0 to 6, square root of x squared dx. Now, square root of x squared is basically x. Let's integrate this function. So the integral of x, you just have to add 1 at the numerator, that's squared, and the number of the exponent, the value of the exponent will be in the denominator. So the integral of x is x squared over 2. So it will be pi x squared over 2, values of 0 to 6. Now, let's substitute the values of 0 and 6 to the x. So it will be pi, let's use 6 first. 6 squared over 2 minus 0 squared over 2. 0 squared over 2 is 0. So we have 6 squared over 2, 6 times 6 is 36 over 2. 36 over 2 is 18. So the final answer is 18 pi.